There are numerous instances. Start over. There are many times where we're interested in two or more random variables having their quantities collected at the same time. Some of the obvious examples just from everyday life might be, if you're in the medical profession, you might be looking at height, weight, and gender being collected simultaneously. Or if you're interested in analyzing sports, you might be looking at, say, in baseball, interesting relationships between number of home runs and the salary that results from that. From an engineering context, examples are exceptionally numerous, but let's look at several here. There might be an interest in wind speed and the direction if you were designing, say, a runway and wanted to know in what direction should that runway be aligned. Another typical kind of situation might be the number of cars and the number of trucks on a highway segment that are happening simultaneously. Particularly, for instance, if you were looking at a bridge and you wanted to know that combination of things for load modeling. Right? Or you might, to follow that, continue to follow that transportation example, you might be looking at the number of vehicles passing a point, and that'd be the actual number of vehicles passing a point in a particular time interval, and then comparing that to the value on a recorder or an instrument. And so although that's a transportation example, that actually goes to a much larger suite of example scenarios that are all about accuracy of the equipment or accuracy of the instrument that we're using. Another very also common one that we might be taking a look at comes from metal fatigue, where we might be looking at the number of cycles to failure associated with the stress range. People like to talk about that in the context of an example of the paper clip, where you bend it back and forth until failure, despite the fact that actually the paper clip example has nothing to do with metal fatigue. That's just large inelastic strain cycles. Number of cycles to failure for metal fatigue are in the order of tens of thousands of cycles, not 2 or 3. But nonetheless, it gets the idea across reasonably well. When we're talking about joint random variables, there's a variety of things that we're going to be interested in here. One of them is that since we have more than one random variable, well then, how do probability laws work when we have more than one variable? For instance, what's the joint cumulative distribution function to describe the way those two random variables simultaneously occur? Or what's their joint probability mass function, say for two discrete random variables? Or if we get into the continuous domain, then we have the joint probability density function. So, and that might be for two continuous random variables. And then there's the possibility here that we have a mixed joint distribution where we have one discrete, one continuous. random variable. And this all leads us to a variety of questions that we are typically trying to address. Those questions that we might want to address are things such as, what is the likelihood that one random variable takes on one specific quantity and the other takes on a different specific quantity? That, remember, that and is code for, in the set theory notation, the intersection event, oftentimes known as that upside down U. Or given our joint probability mass function, say for two discrete random variables, what is the probability mass function of x alone, what we'll call the marginal PDF of x? And likewise, we might be interested in just the y, given that we have some information about the joint. Another way that we might be looking at this issue is, if we know x, one of the random variables, then what is the conditional probability mass function of y? And in shorthand notation, that might be written something like the probability of y given x, y vertical bar x, as the PMF that we're looking at. If you start getting involved in Bayesian statistics, then you use this kind of idea extensively, particularly as you start looking at, say, instrument accuracy, and you have a prior thought as to the accuracy of the instrument. Now you've gone and collected some additional data and some calibration data, and so now what's the posterior updated likelihoods of things, given that you've seen certain results? Other important questions, particularly for analysis and for predicting things in the future, is the primary issue is, are x and y independent? And really, when we say that, we are talking about from the stochastic or random view. And yeah, there's some notion that if there's functional dependence, then there's also stochastic dependence of some sort. We, in our probability world, though, we'll separate out the difference between a dependency that is of a linear relationship as opposed to one that is not. And those are significantly different kinds of things. And there's also the notion that in particularly, say, social applications, we don't know what mathematical relationship there might be there. And so there it is an issue of stochastic dependence. Or go pull back from the social realm and go into the medical realm. For a long time, we could illustrate that there was some sort of relationship between smoking and lung cancer, but we couldn't show what the phenomenological model was or the medical model was, and we still, I think, don't have a pure model that shows why smoking might cause cancer or why in some patients it does not. But there seems to be a preponderance of evidence that suggests that there is a relationship between the two. There's a stochastic relationship between the two. And then we also get to not just these sort of big picture probability modeling questions, but go into sort of statistical measures, and we ask, well, what are the expected values? How do those work in this joint world? So, for instance, just the expected value of, say, y given x, how does that work? Or the variance of y given x. And we also get rise to a measure or an expected value that we've alluded to previously, and that is, what's the covariance of x and y? What does covariance really mean? These are all measures that we're going to be talking about here in our upcoming segments.